Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of NEET Preparation, we'll be looking at previous year questions of physics and medical entrance examinations in India. Today we're dealing with the 7th chapter in the grade 12 syllabus for physics in CBSE. This chapter is called Alternating Current. We'll be studying about alternating current, how it is produced, how it affects circuits, how we can find instantaneous current and instantaneous EMF. And this chapter is very important in terms of medical entrance examinations as well as board exams. So without further ado, let's move on to our first question. An AC circuit containing only capacitance, in this case, the current lags the voltage by 90 degrees, leads the voltage by 90 degrees, remains in phase with voltage, leads the voltage by 180 degrees. So how do we solve this question? So the circuit, it has an AC source and it has a capacitor. So that's why it's called an AC circuit containing only capacitance. When it comes to instantaneous current and instantaneous EMF, there will be a phase difference when there is capacitance or inductance present. Let's look at our following options. Option D leads the voltage by 180 degrees. Phase difference, when there is only one component for resistance, is only up to pi by 2. So therefore option D is incorrect. Option C remains in phase with voltage, so phase difference is 0. This scenario is found when there is only resistance. That means for option C to occur, the alternating EMF must be hooked to a resistor. So option C is incorrect because our circuit contains only a capacitor, no resistors. Option A lags the voltage by 90 degrees. So current is actually coming behind the voltage. So over here, voltage is leading current by a phase difference of 90 degrees. Again, this is present when we have an inductor only in an AC circuit. So option A is incorrect. The right answer is option B, leads the voltage by 90 degrees. So in an AC circuit containing only capacitance, current flows this way and the voltage is coming here. So as you can see, there is a phase difference of pi by 2, and if you look in the anti-clockwise sense, then current leads the voltage by a phase difference of pi by 2. Option B is the right option. Let's look at our next question. A choke coil has low inductance and low resistance, high inductance and high resistance, low inductance and high resistance, high inductance and low resistance. Before we jump in to our options, let's understand what is a choke coil. A choke coil, it is basically an inductor in a circuit which is used to block higher frequency current. And higher frequency means that this has to be an AC current, because alternating current, it goes at a high frequency. And this choke coil, it also allows low frequency DC current to flow. And it does that due to the fact that a choke coil has a high amount of electromotive force, or EMF. So if we look at our following options, options B and C have high resistance in the choke coil. If there is a high amount of the resistance, then there will be power loss and due to this power loss, less current, both AC and DC, flows. So here it restricts all kinds of current. So option B and C are incorrect. What about option A, low inductance? Now, if you remember the formula, E is equal to minus L times di by dt, you would know that the EMF is directly proportional to the inductance. So a low inductance means low EMF. So option A is also incorrect. The right answer is option D, high inductance and low resistance. The high inductance means that there is a high amount of EMF which blocks the higher frequency AC current, and the low resistance that allows lower frequency DC current to flow through the choke coil. Option D is the right option. Let's look at this question. The turn ratio in a step-up transformer is 1:2. If a Leclanche cell of 1.5 volts is connected across the input, then find the voltage across the output. So now we have an EMF of 1.5. The turn ratio is 1:2. So for one turn in the primary coil, there will be 2 turns in a secondary coil. The input coil turns once, the output coil turns twice. So we need to find out the voltage across the output. Now, which of these options seem right to you? Is it 0.1, 1.5, 0.75, 0? Most of us would not consider 0 as an option, but believe it or not, 0 is the right answer. How does this happen? Well, if you look at a question, you see that our power source, or the source of voltage, is a Leclanche cell. And this Leclanche cell is a battery which provides only DC current. And a transformer is a device which works on AC current. So since the transformer is getting DC current, no inductance, whether self or mutual, since there are 2 types of inductances, both will not take place. So no inductance takes place. And since there is no inductance, there is no change in magnetic flux. Whether in this, there is no change in magnetic flux. So therefore, no change in flux across the secondary coil. So therefore, no induced EMF. So there is no voltage across the output. And that's why option D is 0. If the reason why it is 0 is due to the power source. The power source is a Leclanche cell which only provides DC current, whereas a transformer is a device which requires an AC current, an AC source. And that's why option D is the surprise candidate for the right answer. Next question. In a circuit shown below, what will be the reading of the voltmeter and the ammeter? Total impedance of the circuit Z is 100 ohms. So if you look at this circuit, this is an LCR series circuit. We have an inductor, a capacitor, and a resistor in series. And we have the values for VL, voltage across the inductor, VC, voltage across the capacitor, is given. We also have the total voltage and the frequency of the current. We also have the impedance, which is 100 ohms. We need to find this value, the voltage across the resistor and we also need to find the amount of current that is flowing through the whole circuit. How do we solve this question? We have total impedance as 100 ohms, and our voltage output is 220 volts. So therefore, we use Ohm's law. So therefore, in this case, current is equal to the voltage, 220, divided by the impedance, 100. Now that is equal to 2.2 amperes. So 2.2 amperes is the right amount of current. So therefore, option D will give us the right option. So just by calculating the current, the easy way out, we found out our answer. But again, let's verify it. Let's calculate the potential drop as well. Now, the potential drop across the inductor is given as 300 volts. The potential drop across a capacitor is given as 300 volts. The potential drop across the resistor is not known. However, here again, just by tweaking a little, we can understand and we can find out the value for the voltage across the resistor. Now, if we have a current passing through an LCR series circuit, we know that the EMF across the resistor is in phase with the current. The EMF across an inductor has a phase difference of pi by 2. It leads the current. And the EMF across a capacitor, it lags behind the current by a phase difference of pi by 2. So in this case, both the EMF across an inductor and EMF across a capacitor are opposite to each other and they are equal. So VL and VC are equal and opposite. So therefore, VL minus VC is equal to 300 minus 300, which is equal to 0. So both of these components, they cancel each other out. So therefore, the amount of VR will be equal to the total voltage in the circuit. So VR is equal to 220 volts. And if this doesn't apply, then we can always use the formula. V net square is equal to VR square plus VL minus VC the whole square. VL minus VC is 0. VR, we have VR square here, and then on the left hand side we can put in the value, so 220 the whole square. We can cancel the squares out, so the value of VR is 220 volts. The voltage across a resistor is 220 volts. So therefore, the value in the voltmeter here is 220 volts. And using Ohm's law, we got the value of current as 2.2 amperes. So option D, 220 volts and 2.2 amps is the right answer. Let's look at the next question. In a circuit, the coil of a choke decreases the current, increases the current, has high resistance to DC circuit, and no effect whatsoever with the current. Now, if you remember our choke coil, it is an inductor used to block AC of higher frequency, and it also allows DC of low frequency. So if we have a circuit with a choke coil and its source is AC, alternating current, then the coil of the choke decreases the current. So option A is the right option. Option B, increases the current, is incorrect. It does not have any role in increasing the amount of current. And option C has high resistance to DC circuit, which is again incorrect because it allows DC circuit to flow which have low frequency. And option D, no effect whatsoever with the current, is incorrect. This is applicable in the DC scenario, but in an AC circuit the current gets decreased. So option D is also incorrect. The right answer is option A, decreases the current. Let's look at our final question. In a circuit, the current lags behind the voltage by a phase difference of pi by 2. The circuit will contain which of the following? So, in the question, it's given that current lags behind the voltage. Therefore, we can say that voltage leads the current. Both statements are the same with respect to the phase difference. We need to find out which circuit has this property. In option A, only R, when we have a circuit with only resistance, then voltage and current are in the same phase. So option A is incorrect. What about option B, only capacitors? When we have a circuit with only a capacitor, an AC circuit with only a capacitor, then the scenario will be the exact opposite. In this case, the current leads the voltage. That means the voltage lags behind the current by a phase difference of pi by 2. So option B is incorrect. What about option C, an RC circuit? So in an RC circuit, we will have VR in phase with the current I, and we will have VC, which is lagging the current by a phase difference of pi by 2. So therefore, the V net that we get will be having an angle which is equal to omega t minus phi. So therefore, which cannot be equal to pi by 2. So omega t minus phi is not equal to pi by 2 because we have both a horizontal and a vertical component. We have horizontal and vertical vectors, so we need to find the sum of both the vectors. So it is at an angle which is less than pi by 2. So the phase difference is not pi by 2. So option C is incorrect. The right answer is option D, only an inductor. So if we have an AC circuit with only an inductor, then the voltage leads the current. This is the diagram for it. VL leads the current. This is the diagram for an inductor. And therefore, we can conclude that option D, only L, is the right option. And that concludes this episode on alternating current. If you want to access more of our useful content on this chapter or on other chapters in physics, then don't forget to click the playlist in the description down below. Also, if you want to enjoy more of our useful and interesting content such as mind maps, NEET preparation, memory hacks, etc., then don't forget to subscribe to our channel, Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.